Hey everyone, really excited for this chat today as we dive deep into graph technology, the quiet power layer behind serious enterprise AI with the leader in the space at Neo4j. Philip, how are you?
I'm doing great, Evan. Really nice to meet you and be
Good to
here.
have you here and really intrigued by what you guys are doing. Before that, maybe introduce yourself, a little bit about your journey, and how do you describe Neo4j these days?
I've been working in data and databases for a long time, like let's say 3 decades, give or take. And the first two of those, roughly, to round down, to round up, is with relational, and a bit more than the last decade in graphs. And I worked on some of the world's largest database systems on both the operational, transactional, and analytics side, back in the relational world with lots of big companies. And fell in love with this idea, which was at the time counter trend in the early 2010s, to say, instead of making the model simpler so that we can handle simple data at scale, saying instead, no, let's actually go all in on the richness of the data and complex relationships and the connections in the data, figuring that, there are examples from everything from sociology to companies like Google, Facebook, LinkedIn, as well as a lot of networking companies that have entirely built their businesses on networks and network effects. And that has gone well, as it turns out. Fast forward close to 14 years, the company is now, roughly $250 million in revenue, valued at around $2 billion, if not higher, with close to 1,000 employees.
Amazing. And for someone, who hasn't really heard of a graph database, who is mainly working at the application layer, how would you explain why relationships between data points suddenly with AI matter so much?
I'll give you two ways to look at it. One is, if we are just going through our day-to-day lives and trying to understand and assess the things that we encounter, the first thing you do is you identify, all right, what are the characteristics of that thing? But then you really want to try to understand, how does it interact with the world? And if I look at, Google is a great example of, $1 trillion graph company. We all know Google's knowledge graph, which extracts information off the World Wide Web and assembles it into concepts and ideas that are all interlinked and that we can navigate. And then actually their foray into web search was, let's take the relationships between how the web pages are structured and use those to inform how I should rank the results. This one's pretty, I think, a good pointer, an analogy for what we're doing now with vectors and just words and, throwing lots more and more data into the prompt. Turns out there was a meta study, I think around August of last year, looking at 1,500 research papers about prompt engineering, and finding that the more you flood the prompt with lots of raw data, the worse your answer gets. It's actually counterintuitive. And I mean, that kind of sucks, because it's also more expensive to put more data into the prompt and things run more slowly. If you can be more surgical and pull knowledge, so let's extract signal from the noise, figure out how things are connected, and put that into the prompt, you get better answers. And there are lots of ways to use the topology of the system, how things are connected to each other, both the real world digital twin of the domain, as well as, how other kinds of connections, like there's a lot of talk these days about semantics and ontology and metadata and lineage graphs, as well as another kind of graph, which you can create from the vector chunks and how they relate to each other and where they were drawn from and how proximate they are to each other, where in the document they came from, what the collection was, who the author was, and so on and so forth. That can all be represented in a graph.
Interesting. You mentioned you go back 3 decades in data technologies. I worked for Oracle like 10 years ago, different lifetime it seems, but we had hundreds of different databases actually. Why don't traditional relational databases solve these kind of problems? Why can't they be stretched to fit Why do they hit a wall, and where?
It's there are two big areas where they hit a wall. One is if I want to bring in more kinds of data, then as you've probably done hands-on and I have painfully over the years, is you need to rethink your schema. And God forbid you have data in your schema, and it's even worse if you have an application running on top of it. Then you need to really plan your schema change, your schema migration, dropping and recreating tables and foreign keys and constraints, and dropping and recreating indexes just so that you can add some columns and some new relationships and some new tables. So that's one. Is with graphs you have optionality. Some vendors are schema fixed because they're built on top of relational databases. The technology have been building, Neo4j, takes a schema flexible approach. So you have two approaches in the graph world. And with schema flexibility, or maybe more accurately, progressive schema features, where you can choose to lock things down, but it's a choice only once you know what that data should look like. And then I'm going to introduce some keys and some constraints. And until then, I'm just going to let new data flow in, or if I have a new kind of data set come in, because look, from one day to the next, we don't know what data is going to be giving us valuable signal. And, every business is moving so fast. So schema flexibility is one. The second is the way data is written, and the fact that, and I'll speak to Neo4j again, not all graph databases, particularly those based on relational, don't have this quality, but having, it's a term, the term for this is called index-free adjacency. And the idea is that each relationship is its own object, each node is its own object, and each relationship has a pointer to the location in memory, or likewise on flash or disk, of where that where the adjacent node is. So where the node is at the other end of the relationship, and you have this bidirectionally. And what that means is I can use modern compute, which is actually good at random IO. You probably remember when you were at Oracle, I certainly do, of doing everything you can to avoid random IO. Let's prearrange the data on disk in a way that anticipates queries. But you can't anticipate the way things are connected up in the real world. Literally each query, each individual points of data connects in a different way. So you need to lean all the way into random IO. And we did this by saying, let's just pre-connect the data, take a little bit of an extra hit when you're writing the data, so that now when I read it, I can just spider through the data once I've landed into the graph. You can do about 2 million pointer chasing operations per compute core per second. And that ends up being 2 to 3 orders of magnitude faster than a relational equivalent, even faster than a NoSQL equivalent, where you don't have structures to accommodate relating data. And it's much more compute efficient. So as a result, you get queries that are 100 to 1,000 times faster on 1/10 the hardware.
Wow.
And I'll add one more, a couple other benefits that are maybe more C-level benefits that get observed as time goes on with a project. So not the original reason for buying, but the impedance mismatch, i.e., the difference in the shape of the data when data shows up as networks or as hierarchies, and then trying to put that into tables. There's a huge impedance mismatch. The distance between those representations is great. And that ends up turning into a lot of effort, and also just a lot of misunderstanding, because business and the business and the DBAs, and likewise the DBAs and the developers, end up having to speak completely different languages, and then having to spend multi-months of modelers in a room trying to translate between one language and the other, and very few people who can speak both. So having a model that accommodates speaking in technology and business terms in the same way, and having that be the way the data shows up in the world, which is naturally as networks, naturally as hierarchies, naturally as paths and journeys, ends up being in the long a huge differentiator and advantage.
Hi, founders. I'm Mike Lyon, founder and managing director at VistaPoint Advisors. I'm excited to announce a podcast series we've been working on called The Path to Exit. In this series, we'll address topics like when is the best time to sell your business to raise capital, how to conduct a competitive process that maximizes your leverage and options, what factors impact valuation and the probability of a closed transaction, and much, much more. You can find us on Apple Podcasts, Spotify, or wherever you listen to your podcast by searching for The Path to Exit. We hope this podcast is helpful to you on your path to exit.
Wow, fantastic. I'm looking at your website here, so many great logos and customers. Any anecdotes or real world examples of where, your technology really changes how a customer operates? What are some of your favorite stories?
Sure. Let's see. I'll take some obvious ones and then I'll take some less obvious ones. So some of the obvious ones are, of course, a supply chain is a deep nested hierarchy. And it turns out one of the pharma companies who, we all depended on during the pandemic for vaccines had to spin up a super complex supply chain in no time and then have agility behind that. And so one of the big pharma providers actually spun up Neo4j in a very short time and used that as the basis for their entire supply chain throughout the pandemic. That project has since expanded into more than 30 different projects because another characteristic looking at the long-term value of the graph is it inherently accommodates data network effects and use case network effects, meaning the more data I put in there, the better I solve my existing problems, but then the more I'm able to solve new kinds of problems because, I might have 90% of the data to solve one problem, to solve a different problem, and I just need 10% of the new data in, and all of a sudden I can solve 2-3 problems instead of just one. Turning to AI, graphs are kind of have accidentally and naturally become the ideal format for storing knowledge, context, memory alongside LLMs to inform AI systems. And there are two ways in which this happens. And I'll draw from examples that have been presented from Uber, Adobe, Walmart, Novo Nordisk, AbbVie, and many more, that you can kind of boil it down into two patterns. One is I'm going to have your agentic system reach out to the graph, pull more context, meaning the thing and the thing around it and the thing around that, and then kind of subject object in your query several levels out and how they interact. Pull that back, feed it to the model, let the model churn on it, and the model makes a better, more informed decision, and you send that back to the user. The other pattern is, look, sometimes there's no room for error, and I can answer my question through a connect the dots or a multi-hop reasoning is the term you hear these days. Gartner's written at least 3 papers I've seen just this month on graphs as a top differentiator and generally and for financial services, where multi-hop reasoning means, look, my supply chain calculation is something I can do in the graph. It's 20 levels deep. There's a lot of complex math. It's not something a model is inherently built to do, and that's fine. That's why we have multiple tools. So here the model delegates as, say, the right brain, which is spontaneous creative, would delegate to the left brain to solve a particular kind of problem that's more deterministic, reach into the graph, bring the data back, and pass it through. So that's a cool and, for me, kind of new and unanticipated pattern a few years ago before we really understood models or what they were good at and how they could be used.
Fantastic. Enterprises have a number of challenges building AI infrastructure, as you no doubt experienced firsthand. A lot of technical debt, a lot of disparate infrastructure. They're worried about ripping and replacing legacy data estates and affecting existing operations. How do you think about where graph technology, how Neo4j fits into, how they're building? Is it foundational or is it more complementary to what they're doing today?
It can slide in really nicely in a complementary way. So what I love about graphs is, and I've been through now several generations of a whole class of vendors saying, you need to go and take all the data in your entire company and move it in. First, it was data warehousing, and then it was data lakes, and then it's lake houses. And, I understand that CDOs are tired of that. They don't want to be told, you need to move everything again one more time. And the good news is you don't need to do that. You really have a choice of, first of all, when I talked about flooding the prompt with data, I make a distinction between data and knowledge. And knowledge is the signal extracted from the noise and the connections amongst the pieces of signal that you have for the things that are relevant to the particular problem that you're trying to solve. So for your first use case that's powered by graphs, that might be 1% or less of the data that's in your Snowflake or Databricks or BigQuery or you name it. And then that also implies and describes a complementary scenario where you're feeding the graph from an existing repository. So it's a subsetted reflection of the data. The other pattern is, and I'm seeing this a lot in startups now, we've had more than 500 AI startups sign up to our startup program just in the last few months since we launched it. Is they're saying, look, my domain is inherently a network or involves a path or journey. And it's everything from companies that are mirroring an SAP system to keep track of, all the different configuration changes to companies doing, hey, let's do insurance claims right from the ground up, to companies doing just generic AI memory and enterprise search and on and on. And in that case, they're using the graph as the system of record. So much like you would use Postgres or MySQL or any number of other relational databases as your system of record, you can equally use the graph as a system of record. I'll name a few examples that have spoken publicly. Citi Private Bank 8 years ago migrated their system of record from Oracle to Neo4j. Now, I'm not saying that for all the listeners, that the top use, highest and best use right now of graphs is go migrate existing systems. If it's not broken, don't fix it. Go build something new. There's so much new that can be built. But essentially you have the optionality to use the graph as the system of record for some new application or new subject area that's been built that is highly interconnected, and where you need you can derive additional value from going deeper with context. So context and causality, for almost since the time I've been at Neo4j, have been my two favorite terms, because that's ultimately what you get out of the graph, is understanding not just the facts, but the things around it, the reasons behind it. And then causality is butterfly effects. So many things happen in the world every day that are not based on, it's one cause to one effect. It's multiple causes, and then those causes are effects of other causes, and so on and so forth. And they each have different weights. You can represent that in the graph.
Fantastic. Where do you see things headed in the next couple of years? Do you see graph continuing to be its own sort of unique category, or is it just a capability baked into every data platform?
The category's been growing like mad, and that growth seems to be accelerating. And we've had experiments over the last decade where multiple vendors have come in and said, let's just commoditize graphs as a feature, in the same way that's already happened with vectors. Every respectable DBMS these days has added vectors, and vector similarity is a feature, much in the same way, including Neo4j, by the way, much like prior to that, JSON, XML, objects. These have all been absorbed into other database platforms. You might have some specialized databases to the side that are used at the very, very high end, but that's not the norm. So there have been multiple attempts over the years to do this with graphs. And the reality is, if you come back to the benefits that I talked about, schema flexibility, and then 100 to 1000x performance on 10x the hardware for anything deeply connected, those depend on something that's built natively from the ground up for graphs. In other words, you don't get either of those benefits with a relational database. And there are some technologies out there. I'll pick on Google Spanner Graph, where it exposes a graph data model, but only for reads, not for writes. And your data is like literally you have to model your tables and do your writes into tables. So you really miss these benefits. So I have no doubt, look, use whatever technology works for you. And there are going to be, to the degree that a category proves useful, it's only natural that companies that already have data platforms are going to add some level of graph support. And that's great. I mean, that's good for the world. I believe in this as a movement. But for doing anything serious, there's almost like a reverse 80-20 with graphs. You need 80% of the functionality in the platform to get 20% of the benefit. So it's not something that can easily be grafted on. So I believe that plus the fact that the world inherently shows up as networks of biology, ecology, computers, communication, disease, all these things, ideas, as well as in hierarchies and journeys and paths, customer journey, patient journey, that the category is going to become much, much more significant than it already is.
Well, that's a mic drop moment, to say the least. What are you excited about the rest of this year, personally, professionally? What are you up to? What can you share in terms of roadmap or what have you?
We just dropped something that we've been working on for over a decade in different iterations, which is, a knock on graphs, I think, or a limitation has always been, if I have more data than I can fit inside of a single image, then I need to start splitting it up. And about 5 years ago, we actually developed a way of doing this called Fabric, which lets you federate between graphs, so you can split data up and do it thoughtfully. But you need to think about it. And my view as a database professional has always been, I don't want end users to have to think more than they should have. They should think about their domain and their problem, the application that they're building, not how to organize and arrange their data. So we came up with a scaling technology called InfiniGraph, which does a vertical sharding. So instead of splitting up the data sideways so that your graph gets broken up, the graph remains intact, and I'm sharding out my property values, which usually are like 95% of the volume, is the node properties and the relationship properties. That gets done in the background, and so we're pretty excited that 10x is the size of graphs that can be held. We have multiple customers who are actively trying it out. We have some customers who've actually already procured it, and this gets graphs into the 100+ terabyte range.
Wow. And kudos to your brand team, InfiniGraph. It's a great name. Congratulations again on all the success and what you're building. It's phenomenal.
I'll add one more thing is AI has made it much easier to solve some of the really difficult problems that have existed in terms of getting one's data into the graph and learning and using it. So there's now technology, and we have MCP servers and agents and all kinds of tech for this, front ends, for saying, let's just point to a relational database, decide what tables we want, click a button, and then even if there's no referential integrity, which is the case for certain platforms like Snowflake, to infer the graph model and then click the data and bring it over. That we can do thanks to throw the model at in an AI agent, and the LLM basically helps create that. And then likewise on taking unstructured text and doing entity extraction, bringing that into the graph, and then likewise on creating queries, which helps democratize query writing. And a fun surprise has been models are better at writing graph queries using the Cypher language, aka SQL, which is an ISO standard, than they are SQL queries. Because Cypher queries are much simpler and more terse. SQL queries can get very long and cumbersome. So not only do they run better, but models are better at writing these things using a graph language.
Amazing. Well, it sounds like we have a lot more to unpack. I'm headed to RSA, the big security show in San Francisco, in a few weeks, and sounds like a great solution for trust and fraud prevention and data protection, all kinds of use cases there as well.
Absolutely.
So what a cool
top use cases.
Yeah, what a cool environment. So thanks for joining. Really appreciate the insight.
My pleasure, Evan.
And thanks everyone for listening, watching, sharing the episode. And be sure to check out our TV show, TechImpact.tv on Bloomberg TV and Fox Business. Thanks, Philip. Thanks, everyone.